Okay, so in this video, we're going to be looking at how to convert from a number in base 10 to both 3 and base 7. So we're going to start with base 3. The thing to keep in mind about base 3, of course, is that all of the units there's only 3 digits you can use, 0, 1, and 2. And then each of the units are essentially powers of 3. So the first thing that we're going to need to do is we're going to need to find the power of 3, which is as close to 6,783 as possible, but not larger than it. So I'm going to start with 3 to the 6th. That's 729. Times 3 is 2187. Times 3 again is 6,561. So clearly, if I multiply by 3 again, I'm going to get a number that's bigger than 6,783. So that's where we're going to start. That is 3 to the 8th power, I believe. Yes. So for base 3, we're going to start with 3 to the 8th is 6561. And so we're going to figure out how many times does 6561 divide evenly into 6783. The answer to that is 1. So 6783 divided by 6561 is 1 plus some remainder. So what we're going to do is we're then going to subtract, because it only goes in one time, we're just going to take our 6383 and we're going to subtract 6561. If it went in twice, we would have to multiply by 2 and then subtract. And in this case, we're going to get 222 left over. So 6561 plus 222. Now, I need to figure out what is the next largest power of 3 that's going to divide into 222. And I believe that is going to be 81 because 3 to the 5th is 243, which is bigger than that. So 3 to the 4th will be the next power. 222 divided by 81 is going to be 2 plus some remainder. So again, we basically have 6561, which is our 3 to the 8th. And then we're going to have 2 times 81 and something else. So we're going to take our 81 times 2. So we have 2 copies of 81. We're going to subtract that from 222. That's going to get me 60. What's my next power of 3 that is less than 60? That's going to be 27 because 81 is 3 to the 4th. 3 cubed is 27. How many times does 27 go into 60? Also 2 times. So 2 times 27 is 54. So we're going to end up with 2 times 27 plus 54 subtracted from 60 is going to give me 6, I believe. Yes. And then 9 does not go into 6. So 3 is going to go into this twice evenly. And so we'll basically end up like this. Now, if I want to convert this then to base 3, remember that this is 3 to the 8th. So this is 1 times 3 to the 8th. And then 2 times 3 to the 4th plus 2 times 3 cubed plus 2 times 3 to the 1. So if I start with the 1 for the 3 to the 8th position, there's no 3 to the 7ths, there's no 3 to the 6ths, there's no 3 to the 5ths, then there's 2 3 to the 4ths, and 2 3 cubes, and no 3 squareds, and then 2 3 to the 1st, and then there's no leftover digits after that. So this would be my number in base 3. Now I can basically follow a similar process for converting to base 7. So I'm looking for the number, my original number was 6783. I'm looking for the largest power of 7, which is still less than 6783. So 7 cubed is 343. 7 to the 4th is 2401. And the next power of 7, 7 to the 5th, is 16,807, which is definitely bigger than our 6,783. So we're going to, basically our first power is going to be the power 7 to the 4th, which is 2401. So we're going to divide 6783 by 2401, and that's going to give me so 2 and change. So my next breakdown is 2 times 2401 plus 6783 minus 2 times 2401 is going to give me 1981. And so now I need to go down to 343, which is 7 cubed, and I want to figure out how many times does 343 divide into 1981, and I get 5 and change. So my next breakdown is going to be, I have this 2 times 2401 still, that's my 7 to the 4th, and 5 times 343, which is my 7 cubed. And then what's left, well, I'm going to take my 1981 minus 5 times 343, and I have 266 still to account for. The next lowest power of 7 is 49, 7 squared. So I'm looking to see how many times does this 49 go into 266. It also goes in 5 times. So we've got 5 times 49. So 266 minus 5 times 49 gives me 21. How many times, the next power is 7. How many times does 7 go into this? 7 goes into this exactly 3 times. And then I have no constants. So again, keep in mind, this is our 7 to the 4th, 7 cubed, 7 squared, 7 to the 1, and the 0 at the end, the constant, the last remainder is 7 to the 0. So this number in base 7 is going to be 25530. One's digit, seven's digit, 7 squared, 7 cubed, 7 to the 4th. Now, likewise, if I want to go back to base 10, then I just have to keep these digits in mind, these representations of these places, and then basically just undo the math. So if I'm in base 3, keep in mind I only have 3 characters, 0, 1, and 2. So maybe something like 2, 0, 1, 1, 2, 0, 1, 1 in base 3. So that's equivalent to, let's see, this is the zeros placed, 1, 2, 3, 4, 5, 6, 7. So this will be 2 times 3 to the 7th plus 0, 3 to the 6th plus 3 to the 5th plus 1 times 3 to the 4th plus 2 times 3 cubed plus 0 3 squared plus 3 plus 1. So we've got 2 times 3 to the 7th plus 3 to the 5th plus 3 to the 4th plus 2 times 3 cubed plus 3 plus 1. And I get 4756. And in base 7, now in base 7, I'm allowed 7 characters, so 0, 1, 2, 3, 4, 5, and 6. So if I have a number 4, 6, 1, 0, 3, 2 in base 7, then again, this is my 1's digit, this is my 7's, 49's, 7 cubed, 7 to the 4th, 7 to the 5th. So this will be 4 times 7 to the 5th plus 6 times 7 to the 4th plus 7 cubed, 0 times 7 squared plus 3 times 7 to the 1 plus 2. And so I just throw that in my calculator. 4 times 7 to the 5th plus 6 times 7 to the 4th plus 7 cubed plus 3 times 7 plus 2 is going to give me, interestingly enough, 82,000.